3 and we can start. So thank you so much for coming to this talk. My name is Salome and I'm a PhD student at Chalmers and Gothenburg University in Sweden. And my main research topic is researching traceability and what kind of processes and tools we can use to create traceability links between the artifacts that we produce when we create software. So my presentation today is about Capra, which is a traceability tool. And this work is part of a project called Amalthea for Public. And in this project, it's one of an ITEA-funded projects. And its main aim is to deliver a platform that can help improve the development of embedded multi-core and many-core systems. So it provides things like hardware model, partitioning models, things that you can use for your development of multi-core and many-core systems. Now, as part of the project, we also have a big problem of traceability. And so we have an extra tool or an additional to the platform, which we call Capra. And Capra is a dedicated traceability management tool. And we use the word dedicated there to mean that we do not support any other kind of functionality with the tool. So if it's requirements, you have a tool for that. If it's modeling your design, you have a tool for that. If it's coding or testing, you have your separate tools for that. What we do is we help you to connect the different artifacts that you have already produced using these other external tools that you use. And currently, the tool works on Eclipse platform, and that's why we're here today. And I say currently because we have future plans to extend it so that we can also work with other external tools, like, for example, doors, which are popular tools that are currently used in industry. And so I will start with a description of the architecture of our tool. So we have in the center here the generic or the core layer of the tool, and this is where we implement its main functionality. And we decided with this kind of architecture because when we started before building the tool, we asked a lot of people for requirements. What should your traceability tool have? What kind of links do you want to have? How do you want to store them? How do you want to visualize them? And we got very different answers for this. So there was no one answer that you could build a tool that could fit everyone. So we decided to have only the generic part implemented as a core. And then we use the rest of the stuff as extensions or extension points. So we have defined an extension point for what we call the traceability meta model. And here is where you can define which kind of links you want. So in some companies, it's enough to have, let's say, one trace link that says is related to. And you can connect all the things with this one trace. But in some other companies, depending on what you want to do, you want links like satisfied or verified by or refined by and things like that. So we don't fix that. So we have an extension point for which you can create your own custom traceability links and provide it to the tool. Another extension that we have, or an extension point that we have, is for the persistence. And this is how you want to store your traceability links. So for some people, it makes sense that you have one project, for example, in the workspace that stores all the traceability links. And for some, you want to have traceability stored in each project, and for some, maybe you want to have a central location where you store traceability for all the other workspaces that you have. So that is something that we also allow our end users to define. And the third and last extension point that we have is what we call artifact handler. And with artifacts, we refer to things like requirements, models, code, and things like that. And in this case, we also don't fix this because in some companies, you can go and they use doors. In some other places, maybe they use completely different tools. And if you fix the kind of tools that you want to trace to, then the tool is not flexible enough to be used by many people. And we want this to be able to be used by many people. So what we do here is for every artifact that you want to trace to, or for every model format that you want to trace to, you can create its own handler, and the tool will be able to handle it. And for now, we provide just some basic handlers for the common artifacts that are there. And another thing that the tool provides is an API for which you get data that you can use for visualization. So we don't fix the visualization that you need to use, because some people want matrix, some people want graphical, some people want charts, and it's everybody wants something different. So what we do is you have the data, you can read from the trace model, and then you can use that data to visualize however you want to visualize. And the down thing of creating such a flexible tool is that in the beginning, if you give it to the user, they have to do a lot of customization. So they have to implement their own trace model, their own persistent, their own artifact handler, their own visualization and stuff. And for us, in order to deal with this kind of challenge, we have created a default implementation of the tool, for which we can give to the user first, and then they can either use it as it is, or if it's not enough, then they can keep adding things according to what they need. And with that, I will go to the features now that we have for this basic default implementation. So we have two kinds of features. First is the front end, the end user who is actually using the trace tool for creating traceability links. And the other side is the backend. So if you first start the tool in a company, they need to do some configuration. So what can they do in such a setting? So the first feature that we have is in our default implementation, you can create and update traceability links. And here are the different types of artifacts that we currently support. So you can link to EMF, and maybe something that I forgot to mention is that the tool is based on EMF, which means that our traceability model is an EMF model. And for everything else that is not EMF'd, we have a special model that we call an artifact model, for which we store EMF representation of these other tools. So for example, if you want to link to Java files or Java methods, then we store their EMF representation when you choose them. And so in this case, we support tracing to anything that's EMF, because the model is EMF. But through this artifact handler, we can trace to, for example, files and Word or PDF or things like that. If you have a server, like a build server, we can trace to that as well. We use Myelin to trace to task ticketing systems such as Track, or if you use Bugzilla, or as long as it has a Myelin integration, then we are able to trace to tickets to such systems. And we can also trace to C code and Java code. And in this case, with C, we can trace to the file level and say this is a C file, but we can also go down and trace to the function level. And with Java, you can also trace to the Java file or the method level within the Java file. So this is what we can trace to right now. And another feature that we have is a visualization of traceability links. And here, one of the diagrams is not included, but you'll see that later. First, we have a graphical visualization, which means that here you see the pink thing is the element that the user has selected. And this is showing all the other artifacts that are linked to it. So this was a requirement, and it links to some features, some state machines and state charts, some tests and things like that. And we also have a matrix visualization in which you can choose two things, and you have a mark if there is a connection between these two things. And then another last feature that we have is a notification of inconsistencies. So we know that when you create traceability links, sometimes, for example, you link A and B, and then for some reason you deleted B, but you don't remember that, oh, I need to also take care of the traceability link that I was connecting A and B. So we have this kind of basic notifications that you can get and say, maybe, oh, you have moved this file, but it was created connected to a trace link. What should we do with the trace link? And we also provide some kind of quick fixes that you can use to fix. So for example, we can say, how about we delete your trace link since this artifact doesn't exist anymore? So these are the core features that we have when it comes to the user side. This is the end user side. On the back end side, now the configuration side of the tool, we have that you can create a custom traceability model. And here I have an example of a very simple scenario where a person just wants to have a trace link that is called related to, and it links several items. This means that you can use this for everything. And that's one example. But you can also replace this with something that looks like this and say, okay, I want my special trace to be called requirement to requirement, and this will only be used to link traceability between requirements. Or you have a trace link called implements, which will link maybe my requirement to my state machine or my code. Or you have a trace link called tests that should link your requirements to test, and so on and so on. So the idea is you can think of a trace link that makes sense in your context, and then you can define it in a meta model like this. So this we use like XCore or any normal EMF model. And then you plug it into the tool, you implement a few interfaces, and then you have the tool do the rest for you. Another backend feature that we support is the extension of artifacts. So you can always add extra artifacts that you need to support. Like we started saying that our default implementation can trace to these artifacts that we have here. But let's say you think of MATLAB Simulink and say, I want to be able to trace to MATLAB Simulink. Then all you have to do is sit down, implement a handler for MATLAB Simulink, and then the tool will be able to support you with that. Or you want to trace to papyrus models. Then you can implement a special handler for papyrus, and the tool will be able to handle that for you. And the last thing that we have in the backend, again, is the visualization features. And this one, because we provide you with the API, it means you can always take it and then display the results depending on what you use. So for the current implementation, we use PlantUML, but we've also tried Zest, and it works similarly well. So you can use any other kind of visualization tool that you have which is Eclipse-based at least. So enough with the talk. Now we go to the demonstration of how the tool works. And I hope that everything will work. So, and if it's okay, I will sit. So here I have some projects. I use an example that is called HVAC. And HVAC means heating, ventilation, and air conditioning system. So it's a very simple example. And I have the project here. I have some requirements, which are in Reiki format. And then I have just one PDF file for demonstration. I have a model that contains some dummy variants. And then I have the architecture of the tool, and then the behavior. And down here, I have the test for the tools. So I opened them here. So let's start with the requirements. So the idea here is that I want to link my requirements to a feature in my feature model. And then I want to link that feature to a design, and then the design to the behavior, and then the behavior to the test. And I'm assuming that maybe you have the code generated somehow. So how it works, this is our tool, and it's an Eclipse-based plugin. So here I just switched to the Capra perspective. And here I have my Reiki requirements. So let's say I want to trace this requirement. I drag and drop it here to this selection view. And they say I go to the feature model, and this one feature here, I just drag and drop it here. And then I right-click, I say create trace. And for this example, I use the simplest meta model that we have that just has one kind of trace that you can link to everything. So I click related to, and I say OK. Now if you look closely, you will see that here we have a new project that has been added, which contains your traceability data. And we have two models. One is the trace model, and if I open it, see I have one traceability link that is called related to, and it's linking this to artifact, the requirement 3, and the feature called blower. But I have an extra model that is called artifact wrapper, and if we open it now, it's an empty model. Now this is the model where I say that if you link to anything that is not EMF based, then we create a wrapper for it, and it will be stored in this model. So we will see that as we go on. If we create links between something that's not EMF based, then we will see the artifact wrapper has been added here. Okay, so that was between a requirement and the feature. So let's say I remove this from my selection, and I'm left with my feature, and I want to go to here, some components here. I drag and drop my component there, and then again I create a trace link. I say OK. And then I remove the feature now, And then from the component, I want to link it to my state machine. Here I have a state machine. So I just drag and drop it here. Again, I create a trace link. And so far, all I've been doing is just creating traceability links between EMF models. But what I want to do next, I want to link my state machine to my Java tests. So here, I will use this one as an example. So I will drag and drop this file here. And then I will create a traceability link. And now, if I go to my artifact wrapper, I will see that I have one artifact wrapper that has been added, and it's a representation of my Java file that I used to create the traceability link. And we can do more and say, maybe we can even clear this, and say, for example, this feature is somehow connected to this PDF file here, and then I create a trace link again, and so on and so forth. So in this way, we can create traceability links between almost all the stuff that you can have here, so Java, C code, and things like that. Now, another feature that we have is we can use Mylin to create the traceability links as well. So if you come here, I have a track server that is storing task tickets for one of the companies that we work with. And what I can do is, for example, if I remove this and I'm left with my feature and say, okay, this feature again is linked to some of the tasks that here, and I will pick one of the open tasks and put it there. And then I can also create a traceability links between Mylin features, Mylin tickets, like that. So that is how you create traceability links. Now, how do you actually visualize the traceability links? So, for example, if I go back to my Rekif model, and then, sorry, the resolution is so small. And then I go to my plant.uml view, then you can see that here, since I selected this requirement, which we created traceability links for, then I can see how this requirement is linked to all other things. And I have two options here. So I can say, for example, if I say toggle transitivity and then go back and click here again, this is a view that shows me only a direct link. So only links that are coming exactly from this requirement. But if I go back to the other view, then I can see transitively connected elements. So it means that from this requirement to this feature, but also this feature is connected to something else, and that's connected to something else until the end here. And we also have another view that is called the matrix view. So for example, I will clear this selection again and choose something, for example, the components. Let's say these two components are somehow connected. So I will add this component here and this other component, and I will create a trace link between them. And if I select them together, it was this one, oh no, it was this one and this one. Okay, something is not happening. But I have a trace matrix that is supposed to mark an X whenever there is a traceability link between the two components. Yeah, and so these are the features that we have for creating and also visualization of traceability links. Another feature that I will show now is, for example, if I go to my artifact has a trace, okay. So for example, I know that I created a traceability link that is associated with this file here, the HMI control test.java. So for example, for some reason, I don't need this anymore, and I decided to delete it. So I will delete it like that. I will say OK. And then immediately after deleting it, I have a marker on my artifact wrapper because it cannot find this wrapper anymore because I deleted it. But I also have here a warning. And this warning is telling me that this file has been deleted, and it tells me from which location that it has been deleted from. But this doesn't tell you much. But if you right click and you say quick fix, and then you get a quick fix that's telling you if you want to delete the affected trace link. And here, if you say finish, then the error is gone and the trace link should be deleted. So if we go back to our view, here we should not have anything that links from the state machine. Remember, this state machine was linking to the test here, and that's gone for now. Okay, so these are the features that we can use from the front end. But now, for example, I will close all of this. Here I have a papyrus model, and I will open it. And I have a view here called Model Explorer. And then I will clear my selection. So let's say, for example, I want to link between my papyrus model, and as we know, papyrus is EMF based underneath. So if I say drag this and try and drop it there, then I get this warning that we don't have a handler that can support this. And this is because with this kind of view, the elements here are not stored as EMF models, but rather are stored as a tree representation or tree elements. And this is not good for us, because if we cannot support papyrus, I think many people here will run away. So what I show now is how easy it is to extend when you have such a use case and you want to make sure that you support this kind of view again. So a little bit of code now. So I go back here. This is my our tool. So as you can see, the core only has like 2 plugins, which is the core and the UI that deals with all the menus and stuff. But everything else here is an extension. So for example, for the C or for EMF or for the trace model that we have, Hudson and the rest. So before the demo, I created a project here that's supposed to handle my papyrus view. So I will just open that, open project. And then I want us to go inside and see what happens. So first, if we look into the plugin.xml, and if we go to extensions, we see that, this project has an extension. And this, if you can see it properly, it's the artifact handler. I don't know how I can make it bigger than this. Well, it's the artifact handler, and then I pointed to the class. So whenever you want to create a new extension, you need to make sure that in the extensions you define first which extension point you're extending, and then you give the class that will be extending that. And then if we go to the class, we only needed to implement 2 methods. The first method is we want you to tell us if you can handle this selection that we just dropped into the view. And you just have to say, OK, if it's a tree element, then I can handle it. And the next thing that we need from you is we want to be able to have the EMF representation of this element that your plugin can handle. And in this way, we wanted an E-object from this tree element that papyrus gives. And we already have a helper function for that. So we just say get E-object. And then we cast our tree element. And then this method here will return an E-object for which we can store in our artifact model. Now, with this project open, I have to stop my current workspace. And then I will run that again. Where is it? Oh, there it is. So now, if I go to my, it was in the behavior. If I open my papyrus model again, and then I go to my model explorer, and then let's say I try to drag this activity, then that works now. And say, again, another dummy trace, create trace, And as easy as that, you can extend the tool to have more and more views involved. And lastly, we have some ongoing work that's not very complete. For example, if you have build saver, as we said, you can add the build saver here, and you will be able to well, I don't have a build saver now because I closed my workspace. But with the same thing, if you have a build saver here, just like we can drag and drop tasks, you can add the tests that are in your build saver and link them to the artifacts that you have. But I think since we have a few minutes, maybe we can do that. So I will, for example, we use the CDT. Okay. Okay, maybe I will not do that anymore. Okay, so one last thing that I can show is up to now you have seen that when I link to Rekif, I use this sample reflective eCore editor, which is not so pretty because it's not the way we're supposed to use Rekif anyway. So yesterday I decided why not add a new adapter for this lovely view that Rekif already has. So if I close this again, and then I have another adapter here that is called Rekif. And if I open that, so the drill is the same, that you just need to implement these two interfaces. So and I discovered that Rekif, it's an I-structured selection that this table view has, and I just have to cast that into an E object in order to get the object that's that I have selected from Rekif. So if we run this again, it takes forever. Yeah, so now I can go here and open with the actual view. And now you can even drag and drop from this kind of view, and you can create a traceability link. And that's how it works. So back to my slides a little bit. Now that we have this tool, what is our way forward? So first, we want to make it an Eclipse project so that people can contribute with, for example, more adapters and things like that. And as an Eclipse project, we can have a way to support as many artifact types as possible. And one of the things that we're thinking about is including OSLC as well, because if we want to be able to link to tools that are actually in industry like doors, then and they are not all Eclipse-based, then we need a way to move out of the Eclipse platform as well. And then we need more use cases. For example, what would people want to do when they want to update the traceability links? Is the drag and drop for creating actually usable or not usable? And then we want also to integrate some automatic creation and maintenance where possible. So in any places, for example, if you use model-driven to develop or to generate code, maybe it's actually possible to create traceability links between the classes and the code that you actually create. And one thing that we are still clueless about is versioning. So we're thinking in two ways. One thing is that we actually include the versioning information in the traceability meta model, so that we don't actually need to version the traceability model, but we just know that which versions we are linking to. Or the other alternative is also to version the traceability model just like you version any other thing. And every time you update the trace, you have like a new version of the traceability model. But if we have people who have experience, for example, in the EMF store or CDO, it would be very nice for me to talk to them afterwards. Where they could give us pointers on what to do with this versioning. And now, if you have any questions, you're very welcome. And if you want to try out the tool, you can send me an email or tweet me. Yeah, thank you very much. Yes?
So are the trace elements that you can define bound to having like two ends your model that you always have like two elements
Mm.
and link them?
So the traceability model doesn't need you to have two links, and even with the model that I have now, you can link n elements if you want to. So if I do something like that and say create trace, I would still be able to create the trace. And if I go here to my trace model, and it should be the last trace that I created, and then here, this visualization. So it's just one trace that connects 1, 2, 3 things. So it's it really depends on how you define it. So there is no limit.
Yeah. The question would be like, for example, I want to have a trace model that and the elements traced to are named basically. So I can say like this is input physical and input constraint, and this is the code that implemented that. Is it possible to define something like that?
Yeah, I think it should be possible to define something like that. You just need to figure out how you represent that in a meta model, and then as soon as you have that, then it's possible. And maybe also your way of creating traces would be different. Maybe if you select 3 things, that would mean something with this specific kind of trace link that you create.
Yeah, that was my question. If there's like tooling to have something like that, that you can say, okay, these 4 elements, and I want to say, okay, this is the role physical. This is the role constraint, and the third thing is the role implementation.
I think there is a way we can do that as well. Yeah.
Same way, can you attach? Are you planning on attaching any semantics to those links that you're creating? Or
Yes.
The ability to attach semantics to it.
Yes. So our initial idea was that if you define your meta model, then you can have some kind of semantics to the meta model, and say, for example, if I have a link called verified by, and then it should be linking a requirement to a test, and some semantics in that way.
Okay.
On the link. And then you could restrict, for example, if you know the type of requirement in your environment and the type of test, then you could restrict that it's only these that would be possible to yield such kind of a option for trace link to be created.
And the same way, if you've got multiple requirements that are linked like that,
Yeah.
the ability to say that it's an XOR between all of these
Yeah.
would be another
Yeah.
potential use there, especially when you're starting to think about product lines.
Hmm?
In the same way, you had the question with regards to history.
Yes.
In a lot of circumstances, you need to maintain multiple versions at the same time, in which case traceability will have to occur. You'll have to store
Multiple.
multiple versions in there, be able to trace the multiple versions. And there are tools that can do that already, but on the commercial side. So.
I can talk to you afterwards and you can tell me about them. Yeah.
About the artifacts wrappers,
Yeah.
what do you store regarding the artifacts?
Right now we store the name and the URI only.
You can add information about the artifact to extension? Or?
Yes. So the artifact wrapper as well. You define that depending on what you want, and we have it defined here. Actually, it's here. And right now we only store the URI, the name, and which handler is handling it. But for example, if you wanted to store something more, like version or something, then you could add it here, and then you need to fetch that when you create the artifact itself. Yes?
Yeah, I have more questions.
Yeah, sure. Shoot.
So another thing that exists in a lot of modeling tools is there's explicit dependencies. There's explicit traceability that can be derived from dependencies within the model. And I assume that you could actually write some sort of code in your environment to actually discover them, so you can automatically expand
Yeah, the trace model. Yeah.
Because that's very important. The other one is also, depending on methods that are used, or even depending on modeling language, there are implied dependencies that are automatically created. They're not in the model specifically, but they can be calculated. So is that something that could also be handled with your tool?
Yes, so we recently had a discussion with one of our partners, and what they wanted is they have UML, for example, diagrams that already have these associations or something, and would like to also see that in this matrix that you have, because we only end with the traceability links that you manually create. So it would be a possibility that you add language-specific traces, and this could be created on the fly when you need to see them, and then not persisted. So anytime you change the model, you can always recreate the traces. But we haven't implemented that, and we don't know how much effort it will take to have such a feature included in the tool as well. I think so.
You know, do it, so it's more than you think.
Yeah. Is that a don't go there comment, or?
No, because it's extremely useful, because you don't have to create all the trace and elements, because the tool will go and get them from you. And when you get, especially in some cases where in continuous integration scenarios, to get back from test results back into a model, then create an impact analysis, these are extremely useful. But they're very specific scenarios.
Yeah, and I think you need one for every language, so I agree.
I think we should.
Yeah, sorry. Yeah.